Hi, it's Celeste Majors, your canary in the coal mine. And today I'd like to talk to you about a subject you'll probably find kind of strange. And that is the handedness of molecules. Molecules in the substances we take, like the supplements, have not only a formula to them, but they have a shape to them. And the shape matters. You can have things with the same formula that have different shapes, and in the body, they only work in certain locations. It's a little bit like gloves. Okay? Gloves have a handedness to them. And so my left hand goes into my left glove quite nicely. And that's how it would work in the body. Now I can get my left hand into my right glove, but it doesn't fit very well. And if it was something that was part of a chemical reaction in the body, it wouldn't necessarily work real well. Another thing that's kind of interesting is that, okay, even though this is my glove and it fits my hand, somebody with a little bit bigger hand or a little bit littler hand could probably get into this glove. But still, it wouldn't be the best fit. Well, things like that happen in the body. Molecules have a certain shape, they have a handedness and a structure, and they go into certain slots in the body like keys go into locks. And when you have something that's the right fit, it works really well. When you have something that's the wrong handedness, it might not even fit in there at all. Or if you have something that's a little off, it might kind of fit in there, but it doesn't work really well in the reaction. For example, our body has a lot of reactions that involve iodine. Now, on the periodic table of elements, which you might have seen in your science classes in high school, iodine is in the same family with chlorine and bromine and fluorine. And so there's a possibility that those things can substitute for the iodine in our bodies when they actually shouldn't be there. For example, we have fluoridated water now, so you got to ask the question, like, how much is that fluorine substituting in reactions in the body when it actually ought to be an iodine molecule in the thing? Or bromine. They use bromine in bread to make it softer. And so how much is the bromine substituting in places in reactions where there was supposed to be iodine in the body? It's hard to tell, but those things are important in the way your body functions. So I wanted to point out to you that when you go to the supplement store and you want to buy particularly amino acids, they have a handedness to them. And you'll see a lot of them have L in front of it, and other ones will have D in front of the name. Well, D means right-handed, dextro, and L means levo, left-handed. So you want, for the most part, most reactions in the body want the L version, the left-hand version of it. But sometimes supplement manufacturers will use it. It'll be easier to make the D form, and they figure you won't know the difference. So that's just some little thing to watch out for when you're shopping in the supplement store, and just generally to be thinking about how often are things not quite going right in my body because certain chemicals in our environment are coming into a reaction that they shouldn't actually be in to make the body work successfully. So that's probably more chemistry than you wanted to know, but I thought it was an interesting thing that you should look out for when you're buying supplements, that you buy most of the time you want the L version, but check it out on the individual supplement, find out exactly which version your body uses before you buy. So that's it for today, and I'll be talking to you again soon. Be well until then.